This is Honors Algebra 2 Pre-Calculus. We're doing section 9.1 in Pre-Calc, which is series and sequences. So now we're going to be talking about series. So let's start by talking about summation notation. Sometimes you'll hear this called sigma notation because this is the Greek letter sigma. So we're on page 618 in the textbook. The sum of the first n terms in a sequence is represented by, so this is a sigma. Now, if you draw it properly, the top and bottom are parallel horizontal lines with these little like serifs, right? Little serifs, and then this sort of like M. I'll be honest, most of the time mine just looks like a sideways M. So I tried to draw it nicely the very first time, but it's going to look like this most of the time. So on the bottom, we have I equals 1, right? So this I that appears both here and also in this A sub I term, is called the index of summation. It's not always an I. Sometimes there's a K here and a K here. And then this 1 represents the starting value. So in this case, I'm going to start with A sub 1 because I'm plugging in 1 as the first I. You'll hear that called the lower limit of the summation, and you'll hear this I called index of summation. It doesn't have to be an I. It could be a K or a J or something else. The n on top of the sigma represents the term that you're going to stop at. So you're starting at term number 1, you're ending at the term where you plug in n is whatever number. Like this I will be n, right? And that's going to be the sum of the term a sub 1 plus what happens when I plug in the next counting number, which would be a sub 2 and a sub 3 and a sub 4 and a sub 5 and a sub 6, all the way up until I get to a sub n, right? It's not infinite because it doesn't have an ellipsis after the a sub n. This ellipsis in the middle means, hey, I don't know what n is, but I'm going to start at a sub 1 and work my way up until I get to a sub n. Cool. So let's do an example of this. So we're going to take this summation from 1 to 5 of, and that shouldn't be an n, my bad, that should be an I. Sometimes my brain is a little bit slow. So I'm going to plug in this I, right? So what that means is that I'm going to go ahead and find the first 5 terms, and then I'm going to put a plus sign between them. So I'm going to start where I is 1, right? So that would be 2 times 1, right? So 2 times 1 is 1 plus 1, right? So that first term is going to be a 3. Then I'm going to do I is 2, right, which would be 2 times 2, which is 4, plus 1, right? And then I'm going to do I is 3, which would be 2 times 3, so that's 6 plus 1, right? And then I think you're probably catching the pattern. The next one's going to be 8 plus 1 because it's 2 times 4 plus 1. And the next one's going to be a 10 plus 1, right? So that was I is 4 and I is 5. And you wouldn't necessarily write these I values up above this. I'm just showing you so you see how it works. So I'm going to get that this is essentially a 3 plus a 5 plus a 7 plus a 9 plus an 11, right? Which I'm pretty sure is a 35. So, and I'm going to show you a shortcut for how I found that in just a sec, but the short answer is that this is actually a specific kind of series called an arithmetic series, which we're going to do in 9.2. And the shortcut is that 3 and 11 add to 14, and so do 5 and 9. So I added 14 and 7, which was 35, right? 7 times 5. So anyway, so that's a quick heads up on how sigma notation works. We're going to walk through a couple of other sigma problems. In fact, we can probably squeeze another example or two in this video. So let's do a little bit more of evaluating some summation notation, right? So that was our example 11. We'll call this one example 12, right? So again, we're going to evaluate some things. Okay, so let's do, we're going to do the sum from, we'll start with a K this time. So let's do, just for fun, let's do from 2 to, I don't know, let's do 6, right? And what I'm going to do is I'm going to do -1 to the K times 2K. Let's see how that goes. All right, so notice that my index of summation here is a K, right? And this is my a sub nth term, or my a sub kth term. I'm starting at 2, not 1 this time, and I'm going to go up to 6, right? So when I start by plugging in 2, I'm going to get a negative. So if you need to write this on top, that's great. If you don't, it's also fine, right? So I'm going to get a -1 squared, which is positive, and then I'm going to get 2 times 2, which is 4, so I get a positive 4, right? Plus, when I plug in k is 3, I'm going to get a -1 to an odd power, so that's negative times a 6, so I'm going to get a -6. Now, if you want to write this as plus or minus 6, great. If you want to write it as just a -6, also fine. When I plug in k is 4, I'm going to get a positive here again, because a -1 to the 4th, and then times an 8, so I'm going to get a +8, right? When I plug in k is 5, I'm going to get a negative again, right? And then it'll be a 10 because it's 2 times 5, right? And again, if you want to make that just a -10, or if you want to make it plus a -10, that's fine. And then lastly, when I plug in k is 6, I should get a positive and a 12. So I'm going to get a plus 12, right? And again, if you feel more comfortable, you can make this a minus 6. So now I'm just going to add all these terms together, right? And there's a couple different ways to do it. One school of thought is to put all the negatives together and all the positives together, and then you could just do the positives minus the negatives. So that would be their 12 and another 12 that's positive. So I'd get a 24 minus a 16, right, which is going to come out as an 8. That's one way to do it. Another way to do it is just work your way from left to right, right? This will be a negative 2. Right? And then if I add the 8 to it, that's a 6. And then I subtract the 10 and get a negative 4 plus a 12. Hey, that's an 8. I don't care how you get there. Either way, it's an 8. Cool. Let's do one more. So let's do an E13. Right? Let's do the sum from... we'll do the summation as a j. We'll do it j is 0 to, let's do 3 this time. And we're going to do 1 over j factorial, right? So what that would mean is I'm going to do my first term is when I plug in 0. So I'd get a 1 over 0 factorial, right? My next term is when I plug in 1. So 1 over 1 factorial. My next one would be 1 over 2 factorial. And my last term would be 1 over 3 factorial. So if I want to clean this up, remember the trick is to memorize that 0 factorial is a 1. So I'm going to get 1 plus a half plus a sixth. If I wanted to get a common denominator, everybody's denominator would be a 6, right? If you want to put these together first, you could, right? It's up to you. So this is 6 sixths, right? Plus 6 sixths plus 3 sixths plus a sixth, right? So I'm pretty sure that I end up getting 12, right? Plus 3, which would be a 15, plus 1, which would be a 16. So I get 16 over 6, or if I cancel a 2, I get 8/3.